Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. And today we have a fun one. It is optimization in Calculus 1 or Calculus AB. In my opinion, this is the number one hardest topic in Calc 1. The reason why, it combines one of our favorite things, word problems, with relative extrema, first derivative test, critical points, all that. So my number one piece of advice for all of these optimization problems we're going to do today is that even after watching this video, it's not enough. You need to practice more, especially for this topic, because every problem is going to seem completely different. So let me explain how to solve this by actually doing an example problem. Problem 1, let's say I am a farmer who wants to build a rectangular fence around my chickens. The fence is going to have a width of X and a length of Y. And you know, I'm a farmer. I'm not made of money. I only have 200 yards of fence to use. But obviously, for the quality of life of my chickens, I want to have the largest area possible. My question is ultimately, find the dimensions to make that happen. In other words, solve for X and Y. So this is what all optimization problems look like, more or less. This happens to be the most famous and easiest example. So here's how we're going to do it. Step 1, and I recommend writing all these steps as I write them. We're going to need an objective and a constraint equation. The objective is always the thing we want to maximize or minimize. So in this case, it specifically says we want to find the largest area possible. That means our area of a rectangle is going to be our objective equation. And then the constraint equation is almost always the random number in the problem, in this case 200 yards, but really that 200 yards represents the perimeter of my fence. So the constraint equation is always just the number they give you, the constant, and in this case it's going to be the perimeter of a rectangle. So then in this case, my objective is going to be area equals X times Y. And I think this is obvious, but I'll say it anyway, because the formula for area of a rectangle is length times width. Length is X, width is Y. You can use those interchangeably. It doesn't matter. And now for the constraint, it's going to be perimeter equals the random number, 200, equals the perimeter of a rectangle, which I thought everyone knew since first grade, but with my students, almost none of them know the perimeter of a rectangle. So I'll tell you, it's 2x plus 2y. So there we go, we have our objective and our constraint. Now step 2 is going to be solve the constraint equation for one of your variables. And in this case, you can choose X or Y. It doesn't matter. I guess I'll choose X. So in other words, 200 minus 2y equals 2x. I move the 2y over to the other side. And then we divide everything by 2, which in this case, everything's divisible by 2, so it's easy. 100 minus y equals x. Step 2 is done. And then step 3 is to plug that variable into the objective equation, and then we're going to simplify as much as we can. So again, here's my objective and constraint. I am plugging in 100 minus y for x, which will give me area equals 100 minus y, the quantity, times y. Like I said, we need to simplify that. That means I'm distributing the y to both terms, giving me 100y minus y squared. Done. Now step 4. Step 4 is like 3 steps in itself. We need to find the maximums and the minimums. Or in this case, it's just going to be the maximum. And remember, the way we do this is you got to find the critical points. You have to set the derivative equal to 0. And of course, we need to solve it. Then we need to make the number line with my critical points on the number line. I'm making up numbers here. And then we have to test values in between all of the critical points. And finally, wherever we switch from positive to negative, that's a maximum. and wherever we switch from negative to positive, that's going to be our minimum. So that's what we have to do with our function a equals 100y minus y squared. So the derivative is going to be easy, 100 minus 2y. We set that equal to 0, and then we solve for y. Add 2y to both sides, divide by 2. Great, y equals 50. That's our critical point. Now, since we only have one critical point, it is very, very likely that that's going to be our maximum dimension for the area. However, we still technically need to prove it, and to do that, that's where the number line comes in. So 50 is going to go on my number line. I also see some people, they'll make a number line that looks like this, where 50 is still in the middle, but this is bounded between 0 and, let's say, 200, because you can't have a fence that's smaller than 0 or more than the maximum 200. But honestly, this doesn't matter. This is optional, so I'll get rid of that for now. And now I need to plug in points in my derivative, 100 minus 2y. So first I'll choose a number like 1, very easy. 100 minus 2 times 1, that's 98, which is really just positive, that's all I care about. And then if I choose a number like 100 to the right side, it's going to be 100 minus 2 times 100, giving me negative 100, or more importantly, a negative number. Because we have positive to negative, that is going to be a relative maximum, which is great because that's what the question asked for. The question asked for a maximum area. And so what that means is that y equals 50, and in this case it was yards. That's going to be the y value. And then finally, step 5, the last step, is to answer the question. If you remember, this question just wanted us to find the dimensions, which means finding x and y. And since we already found y, that means I just need to find x. How do you find x? You have to plug into either the objective or the constraint. Which one do you think? It is the constraint, so if you said constraint, good job. And remember, we have a very easy formula to solve for x. 100 minus y equals x. That's what happened when we solved the constraint equation. And so then 100 minus 50 equals x. Looks like x is going to equal 50, and that's my answer. The dimension is 50 yards for x and 50 yards for y. And we're done. In some other questions, they'll actually ask you to find the maximum area. If that were the case, I would just say area equals x times y, which is 50 times 50, giving me a final answer of 2,500 yards squared, which is not what the question asked for, but in other problems it could. So there we go. And so this is the general strategy we're going to do for all optimization questions. Let me just review real quick. Step 1, write the objective and the constraint equation. A lot of times this is the hardest part of the problem, and you'll see why later. Step 2, we solve the constraint for one of your variables. Step 3, plug that variable into the objective equation and simplify. Step 4, we find the max or min using first derivative test. And then finally, step 5, answer the question. So we have one more we're going to do today. I encourage you to try this one on your own with our notes that we took. But if you can't do it, that's fine. I'll help you. So for problem number 2, let's say I am Campbell's Soup Company, and I am in charge of designing a new can for our soup that minimizes the amount of metal or construction material I need to make my Campbell's soup can. In other words, I'm saying the surface area of my soup can, I want to minimize that. Now, of course, you know these soup cans, they have a little label, contains this many fluid ounces of soup or whatever. We need to say the volume of how much soup we're holding. And for that, I'll tell you, we need to hold 400 centimeters cubed, which is also 400 milliliters of soup, which according to Google is a normal number. And so one more time, you are going to tell me the radius of this can of soup and the height of this can that minimizes the metal needed while also still having 400 centimeters cubed of soup. So go ahead, pause the video, give it a try, and when you're ready to see the solution, unpause. Okay, so here's what we're going to do. Number 1, the objective. This is the thing we want to maximize or minimize. In this case, it's the surface area of a cylinder. which many of you don't know the surface area of a cylinder equation, so I'll tell you. Area equals 2 pi RL, or in this case height, plus 2 pi r squared. In case you're curious, the 2 pi RH is coming from the sides of the can, while the 2 pi r squared is coming from the top and bottom. I don't think they give you this equation on the AP exam, so if you're studying for this, we need to memorize it. And then for the constraint, that's going to be the number, in this case 400, is equal to the volume of this can of soup. Volume of a cylinder is pi r squared times h. And again, you just kind of have to memorize that. So that's it for objective and constraint. The hardest part of the problem is done right here. What we do next is, of course, solve the constraint for one of our variables. Technically, you can do r or h here. I recommend doing h because dealing with r squared would be a nightmare. So I'm going to just divide both sides by pi r squared, and there's my height, which I'm then going to plug in to the objective equation for step 3. Plug in and simplify. 2 pi r, h is getting replaced with 400 over pi r squared, and then plus 2 pi r squared, nothing to plug in there. And now we need to simplify this. Remember, this 2 pi r is technically over 1, which means I can basically cancel out the pi and one of my r's, leaving me with an r in the denominator, and I can combine the 2 and the 400 to give me numerator 800, denominator is just going to be r, plus 2 pi r squared. There we go, we're all simplified. By the way, since step 4 is take the derivative and all that stuff, I know that this right here is not very fun to take the derivative, so let me take a second to rewrite it like this, r to the negative first power, so I can do an easy power rule when I take the derivative. Again, I have not taken the derivative yet, I'm about to, but this is going to make it easier for me to find the derivative. A prime equals negative 800 r to the negative second, plus derivative of that will be 4 pi r. And then we need to set this equal to 0 and solve. Now I know we put this r in the numerator to help us do the derivative, but now we're going to put it back in the denominator when solving, because trust me, this is going to be a lot easier. And then a couple ways I can solve this. What I'm going to do is I'm going to multiply everything by r squared. Just remember that r equals 0 is not a solution. R cannot be 0 because r in the denominator here would give us undefined. It's a domain error. So that will come into play later. But for now, distributing the r squared, I'll get negative 800 plus 4 pi r cubed equals 0. And now we're just solving this. So I'll add 800 to both sides, and then we divide by 4 pi, and then we just need to take the cube root of that. Now, if I'm not allowed a calculator, I will leave it like this. Actually, technically it's cube root of 200 over pi, because it reduces, but I'm allowing us to use a calculator right now. Let's see what we get. We'll get a radius of 3.993. Yes, that is very close to 4, but we can't round it to 4 because it's not 4. And remember, the units were centimeters. And again, this is not the final answer. Why not? Because we didn't prove that it was a maximum or a minimum yet. We still have to plug it in that number line to prove it's a maximum or minimum. And don't forget, 0 is going on this number line too, because that's a domain error. Meaning 0 I cannot plug in, anything in the negative portion I cannot plug in. I don't need to prove if 0 is a max or a min, because it's a domain error, it's neither, but it is restricting what values I can plug in to test. So in this case, I'll plug in 1 first. Remember, I'm plugging in the derivative, negative 800 over r squared, plus 4 pi r. And if I plug in 1, that's going to be negative 800 over 1, plus 4 pi times 1. Hopefully you can see, even without a calculator, this is definitely going to be negative. And then if I plug in a number like 100 or something, it's going to be negative 800 over 100 squared plus 4 pi times 100. This number's pretty small. It's like 0.008 or something. And then this number is like 400 pi, so it's ginormous. It's definitely going to be positive here. So finally, analyzing my result, negative followed by a positive is going to be a relative minimum. Is that good? Yes, because what did the question ask for? We wanted to minimize the amount of material we were using, which is going to be a radius of 3.993 centimeters. And remember, step 5, what did the question ask for? The question wanted to know the dimensions, radius, and height. Okay, so how are we going to find that height? Well, we said earlier from the constraint, height equals 400 over pi r squared. So 400 over pi 3.993 squared. And that's going to give us a final answer of 7.986. And that's going to be centimeters. So there's our height, there's our radius, and that's the answer. Which I must say, this is a pretty small can of soup, but whatever, who cares? This is the answer. And again, now you should be doing more optimization problems to make sure you understand how to solve difficult problems, because there's a lot of them out there. So thank you all for watching. If you have any questions, please post them in the comments. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.